Is the architect of the Burj Khalifa considered a genius? What challenges must be faced when building the tallest building in the world in the desert? First, the desert is prone to strong winds, and to withstand the possibility of level 12 hurricanes in the desert, the base is the most crucial part of the building. The base alone has a thickness of 3.7 meters. However, in the 1940s, it was impossible to pour such a base in the scorching heat of the desert. Therefore, engineers had to work at night and add enough ice to the water during the construction process. Another challenge in building large-scale buildings is the settlement of the base during the construction process. The base can sink a few centimeters, but these settlements are within the safe range compared to normal soil conditions. However, when engineers placed measuring instruments under the Burj Khalifa and drilled 140 meters, they did not find a solid and hard layer. Instead, they encountered loose sand and weak sedimentary rock. Placing the base on such soil would inevitably lead to collapse if there was excessive settlement. To address this, engineers devised a solution. They inserted a sharp column into the sand, and once it reached a certain depth, the column would no longer sink. The surrounding sand would provide a resistance by friction. Therefore, engineers decided to install these concrete columns under the base, reaching a depth of about 50 meters. In this way, as the base settles, the frictional force of the sand would make the entire base safer. During the construction phase, there was another challenge to overcome. Normally, cement piles can be drilled with a drilling machine, but it is impossible to drill such holes in the desert soil. The surrounding soil would collapse, and the hole would fill with saline groundwater. To solve this, engineers injected drilling fluid into the hole while drilling, creating mud that prevents the sand from flowing and resisting the collapse of the soil. Afterward, a hollow tube was inserted into the hole, followed by the placement of steel reinforcement and the pouring of an exceptionally smooth special concrete. The construction of these underground piles only took 2.5 years, and then a layer of dense steel reinforcement was placed on top. The base of the Burj Khalifa was completed after 6 months of testing. Engineers confirmed that the Burj Khalifa could withstand long-term exposure to wind speeds of up to 240 km/h. They also had to address another problem. The concrete piles under the base, if left untreated, the steel reinforcement inside the concrete piles would corrode due to seawater. To address this problem, they made the steel reinforcement cathodic and used titanium alloy mesh as the anode. Direct current was applied to the system, causing electrons to be deposited on the cathode and preventing corrosion of the steel reinforcement. In this way, they only needed to periodically replace the titanium alloy anode mesh.